Very good morning, children. My name is Anand Kumar Tiwari, and I am PGT Mathematics in Kendriya Vidyalaya 1 STC. I hope that you must be taking very good care of yourself. Now, come back to the topic of relations and functions. And in part 2, children, I had discussed with you about the relations and specifically about equivalence relation and equivalence classes. Do remember that equivalence relations and equivalence classes is going to play a very vital role in terms of marks and very important topic to be revised and to be practiced again and again. Now we are turning our focus from relations to functions. Now this concept of function I would like to illustrate in a different way. I give you one example that will make your concept clear about functions. Say this is the domain and it is containing students of a class. Say student 1, 2, and say the number of students are 50. Suppose, make it 40. Then here we are keeping medals obtained by or secured by students in an event. Now think practically, is it possible that a student is getting gold medal related to an event? Mind it, a student is getting gold as well as silver for the same event. That means I am not associating uniquely. This student S1 is not getting associated uniquely. And whenever uniqueness is not found in relation, it is not a function. That means to make a relation a function, it is necessary that each element of domain should be associated to the elements of codomain uniquely. It means that this student should be associated to only one element. It is quite possible that two students may get same medal. It is quite possible that suppose this is 30 number student and this is 40 number. Their roll numbers are these, may secure same medal. So the condition of a relation to make it a function is that its each element of domain should be uniquely related to the elements of codomain. Now I make some arrow diagram, and from the arrow diagram we try to make our concepts much better. So we take this as set C and this is set D. Then I take one more example so that our concept of functions become crystal clear. Here I'm taking, this is our domain, this is codomain. This is again, say it is D, E, F, it is 3, 4, 5. Now I'm just associating elements from domain to codomain, and we have to check whether that relation is function or not. The definition I have made it clear. Now we can find it out from here. Say A is related to 1, B is related to 1, and B is related to 2, and C is related to 2. D is related to 5, E is related to 3, and F is also related to 3. Now the condition is that here this is not a function because it is clearly visible that B is not uniquely related. B is related to 1 and B is related to 2 children. So that is why it is not going to be function. Another important condition for function is that suppose any student, I take this case, suppose a student of roll number 15 is not getting any medal. First condition was that each student should get only one medal, right? But if it is found that particular student is not getting any medal, is not associated to any medal, that is also not a function. So to make a relation a function, it is necessary that each element of the domain should be associated to the elements of codomain uniquely. Mind it, uniquely. Now take this case. In this case, we find that each element is uniquely associated. So it is a function. So the basic concepts, however, we have studied in class 11, this was just a recap. Now we proceed further and try to find out how many functions we can define from a set to another set. Number of functions defined from one set to another set. We take here this a domain. This is set A, this is set B, and here we are keeping number of elements A and number of elements. Here we are keeping, suppose, m number of elements. Now we are talking about a function which is associating elements of A to the elements of B. Let us see that how many functions. Now A1 can be associated to m ways. That means the first element is associated in m ways. The second element can also be associated, like the previous case, that a student might get any one of the medals, and the second student might also get any number of medals, or any one of the medals, not any number of the medals, any one of the medals, and the A1 student can also get any one of the medals. So for student 1 we have got m options. For the next student also again we have got m options. Likewise for third one, and this will go up to nth student who is again having m options. So this m is repeating n number of times. And now applying fundamental principle of multiplication, we get the total number of functions. Number of functions from A to B, it is m to the power of n. Or in brief, we can say number of elements in B raised to the power of number of elements in A. That is number of elements in codomain raised to the power of number of elements in domain. Take an example that will clear our numerical part also. F is defined from this set to say this set. Now we have to find out how many functions are defined from this set to another set. So number of functions equals to, by this formula, number of elements in codomain is 4, number of elements in domain is 3, so it becomes 4 to the power of 3, which is 64 functions can be defined from this set A to set B, from this to this one, 64 functions. So far the concept, we have understood the concept of function, the necessity of the how to make a function or how to make a relation a function, then how many functions, and also we understood that when we write down from finite set to another finite set, then how many functions can be defined. Now I write down a function in the form of ordered pair. Uh, Not a function, it is relation. And now we have to find out whether that relation is a function or not. Suppose uh, f is any relation defined from 1 to 3. I'm just taking this set only, that will be easier. Defined from this set to this set. Now f1, f2. We take two relations. I'm not calling them as functions. F1 and F2 are two relations such that one is related to A, two is related to B, then 3 is related to C, and 2 is related to D. Then next, 1 is related to B, 3 is related to again B, and 2 is related to leave it, okay. Or 1 is related to C, we keep it. And now finally we take another relation in which say 1 is related to D, 2 is related to B, and 2 is related to C, better to keep 3 is related to C, and we stop here. Now see, f1 relation is a function or not, let us say. Now see, here 2 is not uniquely related. 2 is related to B as well as to D. So since it is 2 is not uniquely related, so it is not going to be a function. So this is not function. F2. Again, 1 is not uniquely related. It is not function. And here all the first elements are uniquely related. Now make a point clear. When we write down a relation, and in the relation, if you observe, if you notice that the first element is not repeating, then and there we accept the given relation is a function. The first element is not repeating, so it is a function. However, this concept we have studied in class 11th also, but one or two questions are there in NCERT. So first element is not repeating, that means it is a function, and if it is repeating, then it is not a function, it is a relation. So so far the concepts of functions in terms of ordered pairs, then function, number of functions defined from one set to another set, then the basic concept of function, the basic definition of function we have studied. Now I move to graph of a function. How would be the graph of a function? Now remember children, the definition of function, and that will help us to draw the graph or to make our concept clear from the definition itself. Now if I draw this graph, now whether this graph is a graph of function or not, let us check it. We take any arbitrary element, say x1. Now see that this x1 is related to some y1. Again it is further related to y2, and likewise it is further related to y3 and so on. It simply indicates that x1 is not uniquely related. I have moved upward direction, you can further move in downward direction also. Suppose this is y4, then this is y5, and likewise this is y6. Likewise, so whenever a graph of when a graph is parallel to y-axis, The graph is not going to be the graph of a function. So function graph is never parallel to y-axis. If it is, if it is function in x we are talking about. So the graph of function is never parallel to y-axis, and that is there. This is actually there in our syllabus also. Graph function in x. Right. Now the thing is that the next concept is types of functions. So for the basics we have done types of functions. Types of functions. Now see, understand the concept of types of functions. First type we are going to discuss is one word functions. Now understand this concept very easily, that when we appear in exams, then each student is allotted single roll number, only one roll number. So we can say this way that these are the students of say class 12th A, and these are their roll numbers, such that roll numbers are 1, 2, 3 and 40. So each student is assigned a distinct roll number, right? This way we can understand the concept of one-word functions. So in case of one-word function, each student is assigned a distinct roll number. So that is, this is how we understand the concept of one function. You can further take an example, that suppose a particular day you go to school, a number of chairs in the class is suppose 35, and the number of students are reaching there also 35, and each student is getting or sitting in one chair only. So each student is assigned only one chair. That is also 1 to 1. That is one function. Do remember that one function is also called like injective mapping. It is a mapping because we are mapping students to roll number. We are associating students to roll number children. So the concept of one function is clear. Now the next is the number of one functions we can define from one set to another set. How many one functions can be? Like take this case. This student can be allotted any roll number. So that means S1 is having 40 options of getting roll number or assigning roll number. S2 will have 39 options. Likewise, if it is goes to S40, so the S40, that means 40th number student will have only one option. Now, total number of functions, if we talk about from, because here it was number of strands and number of roll numbers were equal, so it becomes very easy that 40 into 39 into 38 by the concept of multiplication up to 1, and this is what 40 factorial. But suppose the numbers, obviously the row numbers are infinite. Suppose had it been 50, then how many one functions could be possible? So in the case where the number of elements here in the codomain are more and here it is less, then like this case I have taken. So in that case we can say the total number of one functions is obtained by this formula permutations, where n is the number of elements of codomain and n is the number of elements of domain. And do remember that these elements, that means codomain elements, should be greater than or equals to the elements of domain. It is necessary, right? So n should be greater than or equals to m. This is the example of, or this is the formula of number of one functions. Right. This is to be remembered today. Number of one functions. Now, graph of one function is found to be strictly increasing or strictly decreasing. Like if I draw a graph and it is like this way, strictly increasing or strictly decreasing, or say it is like that, again strictly increasing. So all these are the graphs of one functions. They will be strictly increasing or strictly decreasing. So hope it is clear. That means number of one functions are clear to you, and the one function concept is clear to you. Now we come to the next type. The next type is onto. Onto. Right? Now this is we are uh, relations we have completed, and now we are dealing with the functions to learn. Right? Now the next type is onto. Onto function, which is also called as surjective. Surjective mapping. Now, in the case of onto function, uh, we have a condition that no element of codomain be left unassociated. That means you understand simply the previous example. The particular day the students went to school. 35 students went to school, and 35. Suppose number of chairs were 40, and since the number of students are 35, so we can understand that 5 chairs will not be occupied. So if it is the case that some elements are left in the codomain, then we say the function is not onto, rather it is called into. So we understand both the concept of onto as well as into by arrow diagram. So by arrow diagram, the concept is that this is our domain, this is a codomain, A1, A2 till AM, and say it is 40. That is becomes very easy, because particular number of elements we take, then the things become very easy for us. Suppose B30 is there. We are talking about onto function. Say that it is related to B1. This is also related to B1. And do remember that if two or more elements of domain are associated to single element of codomain, that is known as many one. If two or more elements of domain are associated to single elements of codomain, that is known as many one. One we have already understood. Now continuing with onto, and we find out that A3 is related to B3 and A14. Meanwhile, this is also there. We take that will be take B3, and then we take A4. That will make the concept much better. B4. Instead of 40, it is better to stick to 4 only, and then let us make the concept clear. Now see that in this case what is happening, that B1 is having pre-images. We call pre-images. B1 pre-images are A1 and A2. B2 is having pre-image A3. B4 is there, but B3 is not associated. and since this element is left unassociated, so it is into. This is a case of into. तो into फंक्शन में आपको मिनिमम एक एलिमेंट ऐसा मिलेगा जिसकी प्रीमेज नहीं होगी, मिनिमम मतलब एक से ज़्यादा भी मिल सकते हैं. And suppose यही कहीं we had here somewhere, suppose A5 was there and A5 was also associated. A5 is also, that means B3 की भी pre-image हमको मिल गई. Then each element of codomain is having pre-image in the domain. So we say that the function is onto. Now it has become onto. So I hope that the concept of into and onto is clear. So I make a different diagram so that you can better understand and comprehend the concept of onto. This is say we have taken C, this is D, this is A, B, C, then 1, 2, okay, 1, 2, 1 is associated to A is associated to 1, B is also associated to 1, and C is associated to 2. Now, no element is left in the codomain which is not having pre-image. So this is an example of onto children. So far we have understood the concepts. What? Number 1, that is 1, 1, 1, which is also called as injective. Then next, its subtype, that is many one. Many one you can take that on a particular day you go to class and 2 to 3 students, if a single chair is there, 2 to 3 students have to sit, or 2 students have to sit, because feasibly we have to talk about 2 students are sitting in a single chair, so 2 students are associated to single chair. So then it becomes what? It becomes many one children. Then next is onto. This onto concept we have understood, that how a function becomes onto. And finally, that was into. Into is that one in which at least one element of codomain is not having pre-image, and whenever no element is left which is not having pre-image, it is onto. So this way the types of functions is clear, number of functions are clear, number of one functions also we have done. Now move to numericals, and before moving to numericals, I would just talk about bijective. Bijective functions are the one which are both one and onto. So if I say bijective function, so bijective function has to be necessarily, it has to be one and it has to be onto. These two will make a function bijective, right? So to make a function bijective, it has to be both one and onto. We'll take an example. By arrow diagram, the things becomes much better. A and B, say 1, 2, 3, and here it is A, B, C. 1 is associated to A, 2 is to B, 3 is to C, and no, it is quite clear that each element is associated in a single way, right? Each element is associated in a single way, so it is 1, and no element of codomain is having pre-image, so it becomes onto. So this is a burning or simple example of bijective function. Now, one function we can also understand, or we have to understand by the concept of roster form. In the case of, if I write down add is a one function, or if you are asked to check whether it is one function or not, so I take a set, say 1, 2, 3, and A, B, C. Now I'm saying that already saying that it is one function. So 1 is related to A, say 2 is related to C, and 3 is related to B, right? It is 1 1. Now if I say that this is 1 1, suppose this is there, uh, that 1 is related to A, and 2 is related to C, and 3 is related to B, and 2 is further, 1 and 2 both are related to, say this is okay, 3 to B, and 2 to A. So is it a function? First of all, check it. It is not a function. First of all, sometimes we get confused. This is not a function because 2 is not immediately related. Now one more I will write down, and we, by the concept of ordered pair, we are trying to understand the 1 1 function. In case of ordered pair, if the second element is also repeated, if the second element is also repeated, first element is not repeated, but the second element is also repeated, then it is not uh, an example of 1 1. That means if I make this case clear to you, that 2 is related to C and 3 is also related to C, this case. So 1 is related to A, 2 is related to C, and 3 is also related to C. And since uh, I am coming back to my definition, सेकेंड एलिमेंट रिपीट हो रहा है और हमारा रोस्टर फॉर्म में फंक्शन लिखा हुआ है, तो सेकेंड एलिमेंट जब भी रिपीट होगा, इट मीन्स डू रिमेंबर इट इज नॉट द एग्जाम्पल ऑफ 1 1 फंक्शन. कीप इट इन माइंड, सेकेंड एलिमेंट रिपीट नहीं होता अगर फंक्शन 1 1 है तो, और अगर रिपीट हो रहा है तो वो 1 1 फंक्शन का एग्जाम्पल नहीं होता. So far this we have done. Then let us take some more cases and examples of 1 1 bijective functions. Now we come to NCRT basic concept. F is defined from A to N, where A is class of class 12 students and N is set of natural numbers. And f of x means roll number of student x, roll number of student x. So is this function going to be onto or not, or is it going to be 1 1 or not? We can better understand with the help of arrow diagram. Let us draw an arrow diagram. It is set A, this is set N, and say the number of students in a class is 40 and number of natural numbers is infinite. So each student for exam will be assigned only one roll number, and so on left. Now what happens? This is the case of 1 1. Each student is assigned a unique roll number. So it is a case of 1 1. But there are natural numbers 41 onwards which do not have pre-images. Simply indicates that this is not an onto function, not surjective. It is injective but not surjective. So by just explanation is required that why it is 1 1. So explanation of 1 1. This we have to give that in the explanation we will write down each student is allotted only single roll number, only one roll number. So it is, that is why it is 1 1. And then on to 41, 42, 41 onwards, simply we can say the roll numbers 41 onwards are not allotted to any students, and it means not associated to any students. That is why it is not on 2. So this simple explanation you can give it here. So that clears that whether the function is 1 1 and why it is on 2 or not on 2. Now take one more case. suppose f of x is such that f is defined from R to R, and f of x equals to 3 plus 4x, any function. Now we have to prove that this is a bijective, means it is 1 1 and on 2. Now with the help of arrow diagram, proving 1 1 and on 2 is easier, but when the cases of these types of infinite sets are there, मतलब हमें जब ये समझ में आने लगे कि हमें डिस्क्रीट एलिमेंट्स नहीं मिलने वाले, तो वहाँ पे एरो डायग्राम को अप्लाई करना बहुत मुश्किल हो जाता है, और प्रूव करना, फर्दर प्रूव करना कि वो बाइजेक्टिव है, तो वो तो और डिफिकल्ट हो जाता है. So in that cases we apply or we adopt a generalized method for proving bijective. What is that generalized method is that? Let us understand that and then we proceed to numerical. For that we will take that x1 and x2 are two elements of domain. I take this example. This is okay. Okay, I keep it this one A, that will be better. This will be B. Now x1 and x2 are two elements of domain. And then we assume that their images are same. Whenever I write down f, it means images. So f of x1 equals to f of x2. And by calculations, we reach to the condition that x1 equals to x2. Then we say that the function is 1 1. That's how in a generalized way we prove 1 1. Keep it in mind. In other words, we can also say that if the images are same, then elements are also same. That is the illustration of 1 1. And we can also say if the images are not same and elements are also not same, then also it is 1 1. So both the ways are there. So this was how to prove 1 1. How to prove 1 1. Then next is onto. So proving for onto, we take f of x equals to y. F of x equals to y, like this case, 3 plus 4x equals to y, we take it, convert x in terms of y, so we get x equals to y minus 3 upon 4. And then think in a different way. Y belongs to always codomain, like this case. If I take make it further, r to r, I am connecting this to this. Now see, y belongs to codomain. Y means real number. Real number minus 3. Real number minus 3 is a real number. And when that real number is divided by 4 is another real number, it means this overall belongs to domain. It should be, if it is a part of domain, for every y, for every y, s and e to y, we are taking arbitrary. For every y, if this belongs to domain, then we say that function is on 2. Keep it in mind. In other words also, we have some more definitions of proving on 2. One of them is that if a range of a function, that is a range of a function equals to codomain, that there also, or that way also, we can prove that the function is onto. So these are the two different ways. Now one thing which comes here in mind, that is must to mention, x equals to we got y minus 3 upon 4, ये हमको मिला. और फॉर ईच वाई, अगर हमने क्या बोला आपको, ईच वाई के लिए अगर ये डोमेन में बिलोंग कर जाए, तो मतलब आप ये कह रहे हैं कि y की जो प्री इमेज है वो y माइनस 3 अपॉन 4 है. एवरी y इज एसोसिएटेड टू x, और एवरी y हैज अ प्री इमेज इन दिस फॉर्म. तो समटाइम्स दे आस्क कि आप 3 की प्री इमेज निकालो, तो y की प्री इमेज ये, तो 3 की प्री इमेज निकालने के लिए क्या करेंगे, y को हम 3 से रिप्लेस कर देते हैं. so it becomes 3 minus 3 upon 4 which becomes 0. तो ये इस तरीके से हम 3 की प्री इमेज भी निकाल सकते हैं. तो जब हम प्री इमेज की बात करेंगे चिल्ड्रन, देन आई हैव टू राइट डाउन दिस वे, एफ इनवर्स ऑफ 3. एफ इनवर्स ऑफ 3 मतलब मैंने ये जो 3 लिया वो y के प्लेस पे लिया हुआ. सो एफ इनवर्स ऑफ 3 इज दिस. एफ इनवर्स ऑफ 3 इज दिस one 0. If I ask you what is f inverse of 4, I'm asking pre-image of 4. So in place of y, I put 4 and then calculate. We can find out pre-image. So hope that proving 1 1 in a generalized case, proving on 2 in a generalized case, and then uh, particular definition of on 2. Hope it is clear how to find out pre-image of a particular element when the function is on 2. प्री इमेज हम तभी निकालेंगे जब हमारा फंक्शन ऑन टू रहेगा. It will be asked like that. So find out the प्री image of an element. What is the procedure? How to find it out? That is okay. So we were dealing with this case. We have to prove this is bijective. So to prove it bijective, we need to prove it is 1 1. So we take, as I explained, x1 and x2 are two elements of domain such that f of x1 equals to f of x2. Their images are same. F of x1 we get 3 plus 4x1. This we get 3 plus 4x2. This will be cancelled out. So will 4 be. We conclude that x1 equals to x2 implies that the function is 1 1. Sometimes we have to think this also logically. So this is the 1 1. And on to, we have already understood that the value of x which is coming in terms of y, it is it belonging to domain or not? This we have to check. Right? So last example I will take that will make your concept of bijectiveness much better. Take a condition that we define a function from R to R and it is a greatest integer function. Now we have to prove it is not 1 1 and neither on 2. So we can supply a counter example sufficient. First one 1 1. Why it is not? It is not. Why? Just justifying about 1 1. Now say if I take f of 1.5, suppose image of 1.5, image of 1.5, so greatest integer of 1.5, it is to be 1. Remember the definition of greatest integer. We get an integer which is less than or equals to x, so it is 1. And if I find out image of 1.9, so greatest integer of 1.9 image is again 1. It indicates that 1.5 and 1.9 are both associated to same elements, that is to 1. Both of them are associated to 1 only. So it clearly indicates that the function is not 1 1. Now when we find out the range, so you will observe that the range of this function, it is going to be integers, and since the range is integers, the range of function is going to be integers because greatest integer always yield integers only. So range of a function is integers and codomain, children. What is codomain? That is real numbers. Real numbers. It means that integers have only pre-images in the domain, right? So integers are having only pre-images. Non-integers, like that I ask you, what is the pre-image? Pre-image I am talking about. What is the pre-image of suppose 1 by 2? in this case. So this is not integer. So in this case, what you will say that f inverse of 1 by 2 is not having any preimage, so it is null set. It is null set. So since I am coming back to on to only, we were dealing with on to. So what we are observing that only integers have the preimages in the codomain. Only the integers have preimages in the codomain. This implies that the function is not on 2 because non-integers elements are left unassociated. So this way we have supplied counter example, or by supplying a suitable counter example we can understand the concept of 1 on 2 and bijective. So overall children, in this class we have understood the concept of function, number of functions, types of functions, then how to prove a function bijective, and what I want that in exercise 1.2 we are given questions related to this set only, this concept only. So you can practice them, and if you find some difficulty then ask. Thank you very much. It was a very nice session because the concept of function is found to be by some of the students found to be difficult, but by with the help of arrow diagram, with the help of some suitable examples, the things become very easy for children. So what I want that you practice and start with examples from exercise 1.2. Some examples are there, so you start with examples, that will be much better. And some of the examples which are very important, that I will say you keep it in mind, like example number 9 is there, example number 10 is there, and then in exercise 1.2 this is example number exercise we are taking 1.2, and in exercise 1.2 we can take question number 3, then question number 4, then question number, this is 7, question number 7, both the parts, part 1 and part 2 children. And this question number 9 is very important. Question number 9 is very important children, very important, as well as question number this 10. This question number 10 is also there. So you practice these sums, and before that children, uh, example number 9 and example number 10 and 11, before that example number, so example number 9, 10 and 11 before 1.2 exercise, right? That is to be practiced. So I hope that the concept must have been very well understood by you. And in the next session, we will have different topic that I will tell you when we start the session there itself. Thank you very much. Take very good care of yourself and be safe, and keep the rest of the environment also safe. Thank you.